Right, so let's have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2019, and we're going to have a look at question 5 this time. Okay, so we have here 3 plus 2i is a root of this complex quadratic equation here, and p and q are elements of r, and I squared is minus 1. We've got to find the value of p and q. So if we're told that our roots, we're going to look at the roots of this here. If we're told that one of the roots is 3 plus 2i, in other words z is equal to 3 plus 2i, then by the well, that's z1, this z2, our second root then is going to be 3 minus 2i by the conjugate root theorem. The conjugate root theorem just states that if a plus bi is one of the roots of a complex equation, then a minus bi is going to be one of the other roots. Now this is providing that the coefficients are real, so p and q have to be real, we're told that, and we can see that the coefficient of z squared is also real, it's 1. So if these are the roots by the factor theorem, our factors then are just going to be z minus 3 minus 2i in this case. So in other words, just bring this over here, bring this one over here, and our other factor then is going to be z minus 3 plus 2i. So again, just bring the 3 over here, bring the minus 2i over here, or subtract 3, add 2i. Now multiplying these two together will give us 0, since these two are roots. So all we've got to do is multiply these out. So let's see, we have our roots here, we have our factors here, we're going to multiply out the two factors, which give us 0. Now let's see, z times z is going to give us z squared, z times minus 3, minus 3z, z times plus 2i plus 2zi. Okay, next one then, we're going to multiply out the minus 3, minus 3 times z, minus 3z, minus 3 times minus 3 plus 9, and minus 3 times plus 2i is minus 6i. Okay, last one then, we're going to multiply out the minus 2i. Minus 2i times z is minus 2zi. Next one, minus 2i times minus 3 is going to give us a plus anyway, and then it's going to be 2, 3, 6i. Minus times plus is minus, 2 times 2, 4, and we get I squared here. Okay, so let's just simplify all of this. We have z squared anyway, which is good because we have a z squared up here. Now let's just look at a few things here. Let's look at this here, this one here, we got a plus 2zi, we've got a minus 2zi, so that's handy. That'll just give us 0. We have a minus 6i here, we have a plus 6i here, so again we'll just get 0. So let's just deal with what's left then. We have a minus 3z, minus 3z, so that's these two here. That'll give us minus 6z, so that's perfect. And what are we left with? We have a plus 9 and a minus 4i squared. Well, if we look at this minus 4i squared here, well, I squared we're told is minus 1, so minus 1 times minus 4 is plus 4, so we just get plus 4 here. So we end up with plus 9 plus 4, which gives us plus 13 equal to 0. So that's perfect. If we look at what we have here, what we started with here, z squared, so we were started with z squared plus pz plus q is equal to 0. So if you just look at the coefficients here, with that gives us our answer, which is p is just going to be equal to minus 6, and q then is just going to be equal to plus 13. And that's part A done. Okay, let's look at part B1 then. We have v is equal to 2 plus 2 root 3i, and v, we have to write v in polar form, in the form or cos theta plus I sine theta, where or is real and theta has to be between 0 and 2 pi. So we want theta to be in radians. Now or is our modulus, theta is our argument. So let's say we'll work out r first. So r is just going to be equal to the square root of a squared plus b squared, where we've got an a plus bi type complex number in rectangular form. So in our case then, r is going to be the square root of, let's say, the square root of our a here, which is 2, and then our b is minus 2 root 3. We got to square that. Okay, so let's see what we end up with here. Well, 2 squared is just going to be 4. If we square anything, we're going to get plus here, so minus squared is going to be plus. 2 squared is going to be 4, and root 3 squared is going to be 3. Root 3 times root 3 is 3. So within this bracket here, we end up with 4 times 3, which is 12. So 12 plus 4 is 16. Square root of 16 is 4. So our modulus is 4. So the complex number is 4 units from the origin, if you like. Okay, next thing we've got to do is work out the argument. So we've got to work out the angle here that the complex number makes with the positive sense of the real axis. We've got the real axis here and the imaginary axis up along here. Now our complex number is 2 minus 2 root 3i. So you've got to go out here plus 2, and then we've got minus, so we've got to go negative down here somewhere. So let's say it's here. So this is going to be our complex number v here. This is our v here. So if we look at this here, we've gone out here 2 units, and we've gone down here minus 2 root 3. Okay, now we have to find a couple of things here. First thing we're going to do is look for this angle here. We're going to work out what this angle here is, and we're going to call that alpha. But really we are finding alpha in order to find this angle here. This is theta. This is going to be our theta here. So let's work out alpha first and then use that to find theta. Now this triangle here, if we just draw that the way we would normally draw these things in this orientation here, this would be our alpha here. We've gone out here 2 units, we've gone down minus 2 root 3, but in terms of distance, actual distance, distances are always positive, so this is 2 root 3 actual units. So in order to find alpha here, in order to find this blue alpha here, we're going to use tan, because we have the opposite, we have the adjacent. So I'm going to say tan of alpha here is 2 root 3 divided by 2. So that's just going to give us root 3. So tan alpha is root 3, so we want to find alpha. So alpha is just going to be tan inverse root 3. And if you look up your log tables, your maths tables, you'll find that root 3 is going to be, or tan inverse root 3 is going to be one of these special angles. It's actually pi over 3, 60 degrees in terms of degrees. So it's pi over 3. So in other words, this angle here, alpha, is 60 degrees, or pi over 3. Now, if you look at the entire circle here, going from here all the way around here is going to be 2 pi. So that's 2 pi. Now, in terms of something over 3, some multiple of pi over 3, it's actually going to be 6 pi over 3. 6 divided by 3 is 2. So this is 2 pi. And why did I say 6 pi over 3? Because we have a pi over 3 here. So what have we done? This angle here, alpha, is 1 pi over 3. So we haven't actually gone all the way around to 6 pi over 3. We've gone 1 pi over 3 back here. So this angle theta here is going to be 5 pi over 3. So in other words, our angle theta here is going to be 5 pi over 3. Okay, so now we have the modulus and the argument. So let's just write our complex number out in polar form. So our complex number in rectangular form was 2 minus 2 root 3i. So in terms of polar form, it's going to be or, which is 4, cos theta, which is cos 5 pi over 3, plus I sine 5 pi over 3. And that's it. This is our polar form of our complex number. This is our rectangular form of our complex number. Okay, and that is it really. Let's move on to the next question here. It just says use your answer to part B1. So what we've just done to find two possible values of W, where W squared here is equal to V. So we have W squared is equal to V, and we got to work out what V is, or sorry, what W is here. So I'm just going to go back a little bit here. Instead of writing V here, I'm going to write V in polar form. In actual fact, I'm going to write it in general polar form. So general polar form means that you write it the way we've just written it. So it's going to be cos 5 pi over 3, but you're going to add in a full circle. In fact, you're going to add in 2n pi, any number of circles, if you like, full circles. So if n is 1, you've gone all the way around the circle once, 2 pi. If n is 2, you've gone around twice, 4 pi, and so on. This is our general polar form. So we've got I sine 5 pi over 3 plus 2n pi. Now let me just take this one out. We'll just put in I just put in a square bracket here, just to distinguish our main brackets. Okay, so now what we have to do is find our W. It says find two possible values of W. So really what we've got to do, in order to find W, we've got to square root the left hand side. If we square root the left hand side, we'll get our W. So in order to do that, you've got to square root the right hand side. So really what you've got to do is this. 4 times, we're going to have to revert here, so it's cos 5 pi over 3 plus 2n pi plus I sine 5 pi over 3 plus 2n pi, and we've got to raise that to the power of a half. We've got to get the square root of this entire right hand side. So in order to do that, instead of writing in the square root symbol, we can just raise it to the power of a half. It's the same thing. Okay, let's go again. Now, in order to get the square root of this thing here, you can see really there are only two terms multiplied. We've got this 4 here multiplied by this bracket here. So in order to square root two things multiplied, you get the square root of the 4, which will give us 2, and then you've got the square root, so in other words cos, I'll write it out. When you've done a few of these, you can just do this in your head, but I'll just write it out. Sine 5 pi over 3 plus 2n pi, and let's see, is that everything? Yep. And we're just going to, we've already done the 4. All I've done in this line here is I've just done the 4. I've square rooted the 4 to give us 2. So I've now got to get the square root of this thing here. So let's do that. Okay, so in order to do this, what you're going to do is just use de Moivre's theorem. You're going to take the half and you're going to bring it down in front of the argument, in front of the angle, and multiply. So again, I'll just write that out. Again, you can do this in your head when you've done enough of these, but our answer is just going to be cos a half 5 pi over 3 plus 2n pi plus I sine a half 5 pi over 3 plus 2n pi, and that's it. Now let's just go again. We're just going to multiply out the half now. So we've got 2 times cos. Okay, so here we end up with 5 pi over 6. Multiply the 2 by the 3, 1 by the 5 pi. We get 5 pi over 6. Half here is just going to give us n pi. N pi. So a half, the 2 will cancel. If the 2 will divide into this 2 here, so they'll just give us 1. So we get 1 n pi. And we're going to get the same thing over here. So it's I sine 5 pi over 6 plus, should be a plus here, n pi. Okay, and that's it really in terms of getting the square root of both sides. What we've got to do now is work out both our answers. Now, in order to work out both our answers here, we've got to look at our n here. So we're going to start here where n is equal to 0. So we're going to take n equal to 0, and we're going to work out what our solution would be here. So if n was 0, our first value for w here would just be, so we call it w1 here, is just going to be 2 cos 5 pi over 6 plus I sine 5 pi over 6, because n is 0 here, so this is 0 times pi, which is 0. So let's just work out what this would be. So our first solution here is going to be 2 times, now the cos of 5 pi over 6. Where is 5 pi over 6? So let's just have a look at drawing that and see what happens. Okay, so again, this is our real and imaginary axis. 5 pi over 6 is now just remember, if you just have a look here, we've got 0, we've got pi over 2, we've got pi out to here, we've got 2 pi when we get back around here, so this is going to be 2 pi when we get all the way around. Okay, so we've got 5 pi over 6, which is almost 6 pi over 6. Now 6, why do I say 6 pi over 6? Because 6 pi over 6 is going to be pi. 6 pi over 6 is just pi, so that's from here out to here. We want to go 5 pi over 6, 5 pi over 6, so we've got to go 1 pi over 6 back. So our first angle here, our first root here is going to be here. 5 pi, or first argument really, is going to be 5 pi over 6. So we've got to get the sine and the cos of 5 pi over 6. So this angle here, this is our 5 pi over 6. Now, how do you do that? Well, you look at the reference angle here, which is going to be 1 pi over 6. So this here is going to be just pi over 6 from here to here. This is our reference angle. So let's get the cos and the sine of that, and then work out the sines that go in front of it. So again, you can just look up your log tables. These are kind of special angles, if you like. So let's have a look at the cos of 5 pi over 6. The cos of 5 pi over 6 is the same as the cos of pi over 6. So the cos of pi over 6 is root 3 over 2. So the answer here is root 3 over 2. Now, we got the cos of this angle here, which is in the second quadrant. And remember, cos in the second quadrant is negative, so we've got to put our minus sign in front of this. So remember again that the rules here for this kind of thing, they're all positive here. Sine is positive here in the second quadrant, tan is positive down here, and ASTC then is going to be, cos is going to be positive down here in the fourth quadrant. So we got cos here. Now remember, sine is positive in the second quadrant, so we got the cos of 5 pi over 6. So the cos of 5 pi over 6 is going to be negative. Okay, so that's our answer here. Now let's have a look then at the sine here. Now let's see, we've got a plus here anyway, so we'll put that in for the moment. That might change, let's see. We've got an I, and then we have to get the sine of 5 pi over 6. So the sine of 5 pi over 6 is going to be positive. It's in the second quadrant. Sine is positive in the second quadrant. So all we've got to do is look up the sine of pi over 6, the reference angle. And the sine of pi over 6, the sine of pi over 6 is a half. So we just got plus a half here. We don't have to change the sign. So this is our first first root here. So we've got 2 times minus, so plus times minus is minus 2 times root 3 over 2, so that will just give us root 3. So it's minus root 3, and we have a plus times a plus, which is a plus. 2 halves is just 1, so we just end up with 1i. And that's our first, this is our first answer for, this is our first value for w that we were asked to find. Okay, so that's when n is equal to 0. So let's continue on then and look at when n is equal to 1. Okay, so let's just go back here a little bit. We're looking at this line here now, remember. So we have, let's see, we have w, we'll call it w, w2 here. This is going to be 2. Now it's going to be cos 5 pi over 6 plus, now remember n is 1, so it's 1 pi, so it's going to, we've got to add a pi here, plus I sine 5 pi over 6 plus, again, 1 pi. You should end up with the same thing in both brackets here. So this is what we've got to work on now. Right, so let's just move this up here and start working on this to find out our second root here. Okay, so w2 then, our second root then, is going to be equal to 2. Let's just work this out. We have to get the cos of, now, 5 pi over 6 plus pi over 1. So I'll just work it out here. I'm going to rub this out so in a second because I'm running out of room here, but let's just work it out anyway. We've got 5 pi over 6 plus pi. Now you can think of, because we've got a 6 on the bottom here, you can change this pi to 6 pi over 6. In other words, we've got a 5 pi over 6 plus 6 pi over 6. This is, these will cancel, we just end up with a pi here. So 6 pi over 6 plus 5 pi over 6, that will just give us 11 pi over 6. 11 pi over 6. So that's what we get when we add these two. So we just get the cos of 11 pi over 6 plus I sine, it's going to be the same here. You could just go through the whole process again, but what's the point? 11 pi over 6. That's it. Now let's just get rid of this here. Just to give myself some room, and let's keep going. So we've got our second root here is going to be twice the cos of this here. So we got twice cos. Let's just do our little diagram again and work out where we are this time. So we got 11 pi over 6. Now that's almost 12 pi over 6. 12 pi over 6 is 2 pi. So remember, this is our real, this is our imaginary. So 12 pi over 6 is all the way around here. It's 2 pi. We want just 1 pi over 6 back from that. So we're going to end up down here somewhere. So this is going to, oops, this is going to be our complex number. It's going to be somewhere down here. And this angle here is going to be pi over 6, 1 pi over 6. This is our reference angle. But our actual argument is 11 pi over 6. So our actual argument is from here to here. This is 11 pi over 6. This is what we want to find the sine and the cos of. So how do you do that? Well, same as what we did earlier, you find the sine and the cos of pi over 6, sine and the cos of a reference angle. So let's go through that then. Now the cos of pi over 6, the cos of pi over 6 again is root 3 over 2. So the cos of pi over 6 here is root 3 over 2. Now again, we're in the fourth quadrant here, and the cos here is positive. Remember, it's A, S, T, C. So cos is positive, so it's positive here, so that's fine. So it's plus root 3 over 2. Now we want to get the sine of pi over 6, which is the same as the sine of 11 pi over 6. So the sine of pi over 6 is half, and again, because we're in the fourth quadrant, the sine is going to be negative. Cos is positive, so sine is going to be negative, so it's going to be minus I times half. Okay, so that's just about it. So our second solution here again is going to be 2 times root 3 over 2, which is just root 3, and it's going to be minus 2 halves is 1, which is I. So I think that's it. This is our second solution here. Our first solution, as we can see here, is W1 minus root 3 plus I, minus root 3 plus I. Our second solution is root 3 minus I. So I think that's all we were asked for. Let me just double check the question. Always just go back and read the question again. Use your answer to part B1 to find two possible values for W, which we've done, where W squared is equal to V. Give your answers in the form A plus IB. A plus IB, so we've done that. This is our A, this is our I, and the B is 1. A plus IB, so again here A is root 3, and here B is minus 1. Okay, that's it for this question.